Good day, everyone. My name is Lim Jasin, and today I'm going to present my individual project charter proposal for STIDK 2114 IT Project Management. The project I'm proposing today is called UUM FlexRep, which is a smart course registration and scalable portal system for University Utara Malaysia. In the next 6 minutes, I will walk you through why this project is critical and what are we building, and also how we will measure the success, and also how we plan to execute and manage it. Let us begin. To ground this project in Unity strategy, we look at the core driving force behind our technical evolution, the UUM ICT Smart Campus Initiative. UUM is continually committed to advancing its digital ecosystem to better support its student body, faculty, and administrative staff. Under this framework, automated student services and high accessibility self-service portal models are critical infrastructure pillars. Course registration is not just another isolated software feature, it is the absolute gateway to a student academic semester, affecting timetables, model access, and graduation pathways. When the registration system runs smoothly, the university operations will also run smoothly as well. However, our current legacy card registration infrastructure fails significantly when subjected to high co-concurrency event strain. On registration mornings, which is at 8 a.m., thousands of concurrent student sections hit the central on-premise server system simultaneously. This immediate traffic spike causes server database deadlocks, network timeouts, and eventual total portal crashes. This technical failure triggers a massive negative cascade across campus. This is because the students are blocked from checking out mandatory core modules online, and they are forced to line up physically at faculty administrative offices, flooding staff with thousands of paper-heavy airdrop override steps. This manual process generates a brutal operating backlog for faculty clerks and the academic affairs department, or which we call also HEA. Finally, the human element cannot be ignored. Students routinely waste 3 to 4 hours anxiously refreshing frozen browser pages, which creating an immensely frustrating user experience. For the solution, we introduce you the UUM FlexRec. Instead of attempting to apply minor patches to an outdated system, we propose re-engineering the course registration engine into a resilient, cloud-native, microservice-based architecture. First, we have performed a complete backend microservice refactoring, breaking down the monolithic system into isolated, independently deployable services for seat management, prerequisite validation, and enrollment verification. This ensures that if a localized traffic wave slows down model checking, the entire registration database does not cascade into a crash. And secondly, by migrating the system infrastructure to an elastic cloud environment like AWS or Google Cloud Platform, we introduce dynamic auto-scaling clusters. The portal will automatically provision extra computing power at 8 a.m. to absorb the registration rush and downscale during off-peak hours to manage institutional costs. Crucially, we are introducing a tokenized virtual queue. This digital waiting room safely handles student web requests at a predefined safe threshold, giving users a clear countdown timer and transparent queue position tracking, which immediately stops toxic batch refreshing behaviors. This is paired with an active bi-directional API link to the UUM single sign-on system to eliminate login friction. To keep our execution sharp and disciplined, this project charter defines 3 specific, measurable, and highly aligned SMART objectives. The first objective is our business objective, which is to achieve a 70% reduction in physical and manual airdrop override forms processed by faculty administrating officers during the first semester or live deployment. Second is the technical objective, is to engineer the platform to successfully sustain a peak concurrent stress threshold of up to 10,000 active student sections while maintaining an ultra-responsive page load latency of under 2.5 seconds with 0% server overload downtime. The third objective is our user objective is to optimize the checkout user experience so that any student can securely complete and log in their full semester timetable layout in under 5 minutes once they clear the virtual holding buffer. In the IT project management, a project is only justified if it delivers tangible value to be business case. UUM Fast Track delivers on three quantified value pillars. First, the system availability. We are raising peak registration period uptime from a highly volatile baseline of roughly 50% to a guaranteed 99.99% availability level, translating to less than 1 single minute of unplanned downtime over the entire registration week. Second is the student time savings. We are reducing registration time interaction by over 90%. The frantic, chaotic 3 to 4 hour battle of batch refreshing will be replaced by a structured, predictable 15 to 20-minute digital process. Third is the administrating level relief. By eliminating manual data entry loops, we will achieve an 80% administrating workload reduction, returning an estimated 40 to 50 operation hours per semester back to our hardworking faculty administrating teams. A comprehensive stakeholder analysis reveals how profoundly FastTrack improves daily campus operations. For UM students, the impact is exceptionally high. The virtual queue honors their place in line and eliminates systematic registration anxiety. For faculty administration staff, the impact is equally high. They shift away from being manual data entry clerks, drowning in paper slips, and become strategic queue supervisors approving digital overrides with a single click. For the UUM ICT department, their workflow transition from stressful reactive server patching during registration week to proactive modern cloud ecosystem monitoring using clear AWS CloudWatch analytics. Finally, for the HEA, they receive real-time, clean, unmanipulated student data matrices straight from the cloud database, enabling them to close university enrollment weeks faster and make shift choices on class capacity sizing. To define this project from scope creep and timeline delays, the character establishes rigid execution boundaries. First is the in-scope elements. We cover the refactoring the database into microservices, deploying the auto-scaling cloud environment, initializing the virtual waiting room system, and linking the bi-directional UUM SSO APIs. For the out-of-scope elements, it are clearly drawn that we will not modify unrelated studio portal modules like grading sheets, hostel booking, or financial bursary gateways. We are not responsible for consumer and hardware debugging or student internet connections, nor do we alter core faculty academic curriculum via rigorous policies. For final, tangible deliveries include the production-ready portal framework, the admin system console dashboard, and the load tester queue engine, as well as comprehensive technical architecture blueprints paired with user training handbooks. The execution of UUM RESTWork spans a highly realistic structure 17 weeks roadmap model directly after the 5 standard phase of the IT project management methodology. The phase 1, conceptualize and initialize, takes 2 weeks to align with UUM ICT and secure formal charter authorization. Phase 2, develop project plan and charter, spans 2 weeks to finalize our work breakdown structure and allocate budgets. Phase 3, execute and control is our primary 10-week engineering block for microservice coding, queue development, and SSO system linking. Phase 4, close project takes 2 weeks, dedicated to rigorous load testing simulating over 10,000 concurrent sections, pilot deployment, and official handover. Phase 5, evaluate project success, concludes the roadmap with 1 week post-mortem audit during live airdrop week to measure our performance metric against our baseline MOV targets. Lastly is the task technical risk management and conclusion. We have prepared for technical risk with 3 proactive mitigation strategies, which is to counter the risk of cloud budget overruns from unchecked auto-scaling. We will lock in strict hard upper bound container spawning limits and set up automated real-time SMS alerts for daily spend thresholds. Second, we will resolve legacy database sync failures from high concurrent write volumes. And also we are introducing an intermediate reduced high-speed caching layer to buffer database interactions and stream transactions sequentially without locking the tables. Third, we will address student adoption risk. The queue environment will display clear interactive status visuals, queue positionings, and live facts to eliminate confusions. In conclusion, UUM Flex Rate transformed registration week from an operational crisis into a highly predictable, automated, and data-driven 30-minute process. By replacing an easily overloaded on-premise system with an Agile cloud framework, we safeguard academic timelines, protect critical administrative resources, and provide a world-class digital user experience to our entire UUM community. Thank you very much.